Hey everybody, thanks for joining us at PyRVA. My name is Chris May, and I'm excited to talk to you about refactoring tonight. I think that refactoring is probably one of the best skills that you can learn to level up your career. It's something, the amount of time that you invest in refactoring will pay off across your entire career. It'll elevate you in the eyes of your coworkers because you'll be able to do more things to implement features faster, and you could teach them how to do it too. It's really great. So let's talk about refactoring by starting off with what we developers do on a normal basis. As I've listened to other developers and as I look at how I work, I notice a trend in how we approach our code. It's like when we have a new feature that we need to implement, we will kind of open up our code, in whatever editor we want, and look through to see what patterns there are, and like how would this feature hook into the code that exists today. And usually what we'll do is see if there's some kind of like feature, a pattern that we can use to kind of hook it in, right? And this is not a bad idea. The issue is the more we just kind of jump into our code and look at it and see how we can plug in new features, the harder it becomes to change our code. Over time, we could just have a big jumble of mess. And so the way that we can kind of work against this to kind of unwind some of these things is to refactor. So the question is, what exactly is refactoring, right? Because for myself, I've heard of refactoring for much of my career, right? But I never really understood what exactly refactoring is. Even the teams that I was on, many times we would use the term refactoring, but I never really understood what that meant. I just kind of like mimicked what I saw other people did. So let's start with a definition. Refactoring is changing the structure of code without changing its behavior. And, honestly, I feel like that definition is lacking a little bit. Because you can change, like, say, a doc string or some documentation in your code, and technically that would be refactoring. But I feel like refactoring is more than just that. It's also about coming up with a better understanding of the problem in your code and allowing concepts in the domain of your problem to emerge and to use those concepts to help to solve problems, to implement new features. And while we use design patterns a lot in refactoring and in our development work, refactoring is not about using as many design patterns as you can. Or learning about new design patterns and using refactoring to kind of leverage them into your existing code. It's not about that. It's about balancing simplicity, readability, which is very important, and changeability or flexibility. So to talk about refactoring, I'm going to use something a little surprising, I think, to talk about refactoring, and that is the song, The 12 Days of Christmas. And it's kind of weird, right? It's August, but, we all need a little Christmas now and then, right? But the real reason is that songs in general can help us to talk about code, and especially refactoring, because they kind of have an algorithmic quality to them. So we can look into code, into songs and code them up and use them as practice without getting bogged down in real world details. So how do we begin? Well, in order to refactor, we need code to refactor, right? So let's create code that generates the 12 Days of Christmas lyrics. And that's what we have here. Essentially, it's nothing amazing, right? It's just the code, the lyrics, right? A function that returns the lyrics. That's all we need. So, and we're going to refactor it anyway, right? So do we go ahead and get started refactoring? Because we could, no, we don't. We shouldn't start refactoring immediately. In fact, whenever you stop and think, okay, it's time to refactor, you should ask yourself one very important question. And that is, should you even refactor at all? And I would say that you should not refactor unless you can answer a couple things. You can say a couple things are true. First, are you implementing a new feature? If you're implementing a new feature, you have an idea of where your code needs to go, right? If you don't, you are working on your code and you can introduce complexity for no real reason. That's one reason, but to me, another big thing is that you can just waste so much time. And this is coming from my experience. I have spent so much time, looking ahead and seeing like what different projects. I've looked ahead to see how I think we're heading, and I've spent time trying to make things easier or make things better for us, and just to have things not turn out that way. And I've had to throw away a bunch of code, or have all these branches in my Git repos that I don't remember which one's which, and it's just a waste of time. It's a waste of mental capacity, unless you want to do it for practice. That sure, but in real life situation, you need to be implementing a new feature. So that's number one. Number two, the question you need to answer is, do you have tests? Tests are the wall at your back. They are your rear guard. They're your brother in arms. They are your proof that your behavior hasn't changed. And so tests, I love having tests around. Honestly, many of us don't necessarily have tests in many of our projects. I know most of the teams I've worked on, we have not had that many tests. But when it comes to refactoring, it's very important to have tests, because it's so wonderful to do a bunch of changes and to run your tests and have them all pass and know, like, okay, good, I did that correctly. I have the confidence in my code that I can move forward on. So if you have these two things, if they're true, then I say go ahead, start refactoring. So I said that we need a new feature, right? And I said that we're going to be refactoring the code that generates the 12 Days of Christmas lyrics, right? Well, we have a little problem right there, right? Because these are the lyrics, these are the gifts that are given during the 12 Days of Christmas. And they haven't changed in, I don't know how many years, hundreds of years probably, right? So I'm going to define a new feature for us. I think that we should support new gifts. In doing research on the 12 Days of Christmas, I found out there are multiple versions of the 12 Days of Christmas. There are joke versions and things like that. But apparently in Nigeria, there is another version of the 12 Days of Christmas that have completely different gifts, and apparently don't have anything happening on the seventh day, which I'm really curious what happens there or how that got left out. But irregardless, that is our new feature. We are going to support customizing, changing our gifts. Cool. So we have a new feature. We have our code. Next thing we need is tests. And I didn't create any tests for this, like if this were real code, if it's running, if it's working, and you don't have tests, that kind of makes sense, because, if it's been working and it's been fine, why would there be tests, right? So I think part of this is to show you how you can introduce tests pretty quickly. In this case, you need to start by creating a new Python file. This one I'm calling test_song.py. And then I'm just going to copy the code verbatim, right? This is the song. I'm copying it from the other document. And then I'm going to import our function from our other file and use PyTest and say assert. When you call the function, the result will equal the song. And so if we run that, we can make sure everything is hooked up, and it is. We get our passing tests. So that's great. Now, we've got our new feature, we got our tests, we're ready to refactor, right? So the main question you need to ask is it clear how to add the new feature? Most of the time, let's look at our code. Is there an easy way that we can see how to add a new set of gifts in here? The answer is no, right? It's pretty rare that when you approach a project with a new feature, it's pretty rare to be able to say like, oh, I see exactly how I'm going to hook this in. So usually what you need to do to start implementing a new feature is to not actually implement it, but to kind of rearrange the code to kind of unwind things so that you can figure out where you can insert the new feature into your code and have it work. So let's do it, right? This is like, the third time we've seen this code. But the question is, I feel like many times this is kind of the hardest part about refactoring. You have code that works. You have a destination, a new feature that you want to add. But what's the first step? Where do you go, right? What's the first step you make? There's so many options. I think the best way to start is to consider code smells. Code smells is another one of those terms that I've heard for years, but I've never really understood what they were up until recently when I've done research on it. Because if you were a part of my teams, it seemed like the idea of code smells is that they are my opinion on why your code sucks, But that's not it. It's not about opinions. Well, I mean, as humans, we all have opinions, right? But code smells are actually a specific number of suggestions that have been collected over time and been collaborated by many smart developers to create a list of specific things that can be improved in code. And in fact, each one has specific practices that you can use to make code better. One more thing I want to say about code smells is that just because your code has smells, right? I think pretty much every code will have smell, no matter what. You don't necessarily have to fix every single one of them, and that's one reason why I like this, the term code smells, is that some smells are like light aromas. You barely can smell them at all. Other smells are pungent and really awful, and you need to change it, right? Same thing with your code. Sometimes things might be technically a code smell, but it's working fine. You don't need to worry about it. And so speaking of code smells, I mentioned there were a specific number of them. There are more than 20 code smells that you can use to look at your code through. Some of them may sound familiar to you, like duplicated code. Others have really interesting names, like shotgun surgery. That's one of my favorite ones, I think. And I think it's well worth time to look at code smells, if you're not familiar with them, to read through them and understand them. Because just by knowing code smells and understanding them, they will improve your code many times. So, looking at our code one more time, is there any code smell that appears that kind of jumps out at you? Well, for me, when I was going through this process of refactoring, the code smell that jumped out at me was duplicated code. Because if you look at it, there is definitely duplicated code. It's not exactly straightforward, right? Because there is duplication in between the verses, and this looks very similar, but there's also duplication within the verses that's kind of a little different, right? I'm getting a little ahead of myself, but the point is that it's not exact duplication. It's not the same thing over and over and over and over. There are parts that change that are embedded within parts that stay the same. And so in order to kind of get at that, I think it'd be great to kind of pluck each verse out and to deal with each verse individually. So to do that, I'm going to add a layer of indirection. And what I mean by that is I'm going to create a conditional, a bunch of if statements to create conditionals to separate out the verses. Something like this. So we have this conditional, and now I'm just going to wrap it in code that accumulates it, joins it together, and returns it. And essentially, I kind of replaced our previous function with this function. Now, just to be safe, I did a bunch of work, right? I deleted our old code. I'm going to run our test to make sure it works. Awesome, it does. Cool. So now I have the confidence that it behaves exactly the same as it did before. So I have this new function, and I have new code, but really what I really want to focus in on is just the conditional, just the verses themselves. So I'm going to take it one step further and extract the conditional into a function by itself. So I'm going to scroll down. I'm going to create the new function that's just the conditionals, just the verses. And then I'm going to come back up and replace my previous code with just a call to that new function. And, now that I look at it, we can change our code because it could just be a list comprehension, get rid of the old code, and have recite be a nice, tight, little, small function. Now that I've done some work, I'm going to just make sure I'm confident in what I'm doing. I'm going to run our tests again, and they pass. Good. Perfect. Because now what this means is like we can just focus just on the verses themselves. And looking at them, this will give us the ability to tease apart the parts that change from the parts that stays the same. And one thing I learned to do this, there's a Ruby developer, Katrina Owen, who I learned this from, and I think it's a really neat idea, which is, wouldn't it be great to like separate out the parts that stay the same, which like many times when you have a pattern like this in strings, you can say there's a template and then there's data inside the template, right? This is very popular in like web development, right? You have a template for different pages and you just want to inject data into that template. So the same thing here with strings. We have template and we have data, and we want to kind of extract them so it's clear like what is template, what's data, what stays the same, what changes. And Katrina specifically mentioned that one great way to do that is using the percent formatting, the old percent formatting method in Python. And honestly, I am all for f-strings. I'm not saying that we don't use f-strings. I'm saying this is a really cool idea to kind of physically remove the data from the template so that you can look to see the things that change. So for instance, let me perform this change to our code. And as you can see here, we have, essentially I've just done it just for the first thing. It's like the nth day of Christmas now gets pulled over, right? But even just doing that, it's interesting that there's already a pattern that's starting to emerge. We have two different parts of the duplication, right? And one is, addressing the different kinds of days. The other is, has to do with like what you're given, the gifts, and it's a little bit more complex, right? It's almost saying like between the two of these, this is going to need to have some kind of algorithmic component to it that needs to emerge. Because after all, like you start off with a very simple verse, but then right as soon as you get to the second verse, it gets very different, right? You accumulate gifts, but you also have an and statement. And as you go through all the verses, they just keep accumulating more and more and more and more. It changes, but it's kind of predictable. I'm really interested to see how we're going to solve for this. But really, the other thing that comes from this is that we now know we have a template string and we have two things that we need to inject into that. There's this pattern that has developed. And now there comes a tricky part. Knowing that we have two holes that we need to fill, I want to name them. Because if we can name them, we can develop something that can help us solve the situation. And when it comes time to for me to figure out how to name something, or I like to kind of bring up a spreadsheet, a table, to kind of help me think through things. Because in this situation, in our code, we have the variable named number. And so when number is 1, this first thing needs to be first. And the second variable needs to be a partridge in a pear tree. When number is 2, that's the next row down, right? The first variable needs to be second, and the second variable needs to be 2 turtle doves and a partridge in a pear tree. And so naming is challenging, right? It's one of I've once heard it said that there are two hard things in computer programming, right? Cache invalidation, naming things, zero-based indexes, and off-by-one errors, right? So naming is one of the hardest things. So I want to talk about a couple strategies we could use to come up with names. The first is just something convenient, right? Something that we can just grab from, what we can see on the screen and just kind of name it. Something quick. So for instance, number, string, and things, right? These are very convenient variables that we could use that describe what we need. Unfortunately, when you just kind of grab a variable name out of the sky or out of the situation that surrounds you, things can get out of date pretty quickly. In fact, I've seen a function that is called blue and returns the hex code for red. I don't know how it got this way, but the point is that things can get out of date. Another option is to use something that's like within the template, right? So like in this case, say day or items. These I feel like are better because they are a little more tied to the situation we're in. I'm not like I feel like they may not be the best, but they're not too bad. They're definitely a level better. You could also come up with like structural names. In this case, like the first variable could be because it's the first variable that you need to replace, or the first value is first, so that could work. I don't really feel so great about that. Grouping, it's a little generic, but it's an option. All this to say is that when it comes time to come up with names of variables, I think the best variable names you can come up with is when you take a step back and think the problem space I'm in, the domain of this program, the business use case. If you can think about that first, I think that can help create good variable names. So in this case, let's think about what would be the first variable name for this template. We could say day. I think day, we mentioned it earlier. It's not bad, it kind of fits. But I was thinking it doesn't work for two reasons. One, it's like if we were to use an F string in here, it'd be on the day of Christmas, and that just doesn't quite fit for me. In addition, it's not a day. It's something that modifies the day, right? So like maybe the nth day, that's not bad. But the more I think about it too, the more I think about it, the less it has to do with a day, and the more it has to do with a number. And so it's kind of a weird name, but I'm thinking if we just use nth, that kind of works. It's a little odd, but I'm going to go with that. So now the second variable, right? How about the list of gifts, right? Because as part of this domain, you're definitely getting a list of gifts every day. But a variable named list of gifts is sometimes hard to say, and it's long. So if we just kind of swap it around, we can make the name a little shorter, gift list, and that's not bad. Though it's not always a list, right? Like the first day, it's actually just one gift. And you can kind of say like every day, you don't necessarily get a list of gifts, you get a gift. The gift happens to be multiple gifts, but it's just one gift. So maybe we just use gift. I think that works. So we have two names. Let's start implementing these ideas in our code. So let's start with nth. Let's create a function, nth, so that when it's given a number, then we can return a word that describes it. So let's just start off, right? If integer is equal to 1, we're going to return first. And I feel like at this point we've got an implementation. Let's just see, we've got our first step. Before we go down the whole line, let's just hook it in, see if it works, see if it feels good. So go back, pull our code back up, and in our first verse, I'm going to put in a call to nth and pass in the number, and just to make sure, check to see if our tests pass, which they do. So now I'm just going to go ahead and fill out the rest of the nth function, and then fill it in all of our code. Now, let's talk about gifts. Gifts, we need another function, so let's create it. Gift. Gift is a function that, given a count, returns the accumulated gift. This one's a little more complicated than nth, right? I kind of mentioned it earlier. We have the first day is pretty simple. We just need to get the gift, right? But then for every other day, we need to accumulate a list. So I'm just going to create a function that does that. We have all our gifts defined, and we have code that will just get just the gifts we need, everything from, essentially today earlier, join that to the partridge in a pear tree, and, I should say reverse it so that it's in the right order, and we should be good. We'll go ahead and hook that into our first verse, run our tests. They pass, we should be good. Let's go ahead and fill them in for all the other verses. And all of a sudden I stop and look at this. And you know what? This is duplication we could do something with. If you notice, every verse is now exactly the same. So now we can make a little room at the top, add an early return statement that just returns the template and a call to our functions, and get rid of the rest. And now, you know what? I'm going to take it one step further. Now that we know what we're doing, I'm going to convert them to F strings. And now it makes it really clear exactly what we're doing. I have a nice little tight, short function that will render the verse. And just to make sure, let's run our tests. And they pass. Excellent. Cool. So I feel like we've made an improvement to our code. It's not one big block of text anymore. It's now, 4 functions that are pretty understandable. I think we've made some improvements. But of course, the question now is it clear how to add the new feature? And looking at the code, no, it's not. It's not yet clear to me. Like I'm at least when I was working on this, I was just thinking, like, looking at this code, I still didn't know how I can implement this feature. Some people might be able to take the leap from here to a good implementation. Myself, I needed another thing, another look through, another thought of, are there any code smells that are jumping out at me? In this case, the case switch statement code smell jumped out at me. And let me explain this a little bit, because case switch statement is, or let me take a step back. The code smells in general were created by programmers who work in C or the C style languages and Java and things like that. So they use case and switch statements far more than we do. In Python, our switch statement only came in 3.10. In Python, this is more of like a collection of if else statements, like a big block of if, elif, or if. And it's not so much that a collection of if statements or a conditional block is a bad thing. It's more that collection could be hiding duplication, or it could be hiding an idea that wants to emerge. So in this case, we have a lot of duplication that we could just make simpler, right? We've got a 26 line function that we can make a lot less. So I'm just going to do a quick little refactoring by putting all of our gifts into a list, and in return, accepting an integer and just returning the nth version of it, right? Adding zeroth to make sure, so that if you pass in 1, it returns the first, which is good. Cool. So now that I've made that refactoring, is it clear how to add the new feature? And as I look through our code, all of a sudden I just had this thought that hit me when I got about here. I realized, looking at these two lists right here, the nth and the gift, something occurred to me that didn't occur to me before. That there's like a strong connection between nth and gifts, right? Earlier when I talked about we need to name things, in my mind I was thinking we have 3 separate things, right? We have 3 variables, number, nth, and gift. Well, and it turns out there's a very strong correlation between these. So they're not 3 separate things. They're actually 3 parts of one thing. And so what we need to do is come up with a name for that. And so I'm thinking maybe verse seems to work really well. So let's create a verse. Let's start off by creating a class. And I think class would work well here because we need to, well, let me hold on that. More than just a class. I'm thinking, at this point I was thinking about the problem itself. We want to come up with a way to make it easy for users of our code to provide a new set of gifts, right? A custom collection of gifts. So I think that instead of just a class, I'm actually going to turn it into an enum. And if you're not as familiar with enums are essentially saying, this is given the situation that the enum is, in fact, let's go ahead and put up this situation, right? Given the situation of the 12 days of Christmas, there are only but so many options you have. In this case, you have 12 options, the 12 different gifts of Christmas, of the 12 days of Christmas. And so what I like about this is, like, if we solve this problem using an enum, we should be able to allow people to create their own enums and put in as many or as few as they want and customize the gifts. So I think this is going to be a very interesting solution. The issue with this implementation, as it exists right now, is that we're using numbers to access the gifts. And there's no quick and easy way, although I did just think of one, but as I was working on this, there is no quick and easy way to say like, hey, I want the sixth verse, right? With enums, you could either say, give me sixth, or give me the enum that matches the value. In this case, like say 6 geese laying. We don't have that. We have the number 6. So I'm going to change this enum to support that. And it looks like this. Now, this is most times when you work with enums, you're not implementing a dunder new method. So let me explain what happens here. With this code, if you were to have a REPL situation where you ask for, say, the 4th verse, pass in 4 to the verse enum, it will give you the 4th verse. The way that works is normally when you pass in a value in between the parentheses for enum, it looks on the right side of the equal signs. And if there's a match, it'll give you that enum member. But in this case, since we're passing in a tuple of 2 things, in the new method, I'm essentially saying, take the thing that comes in, it's going to have a number and a gift. Take the number and assign it to the value of the enum of each member. That's what the single underscore value variable means. In addition, I'm taking the gift parameter and I'm saying to the single underscore or the under gift attribute on the member. This will come up later. So we have our enum. We have our choices. I mentioned that we our nth function now needs to move on to this object. So let's implement it. So the way I'm going to implement it is through an nth property, a function, a method on this class that essentially just returns the name, which would be say if you had, for example, the 4th verse. If you were to call nth, it would take the name 4th, lowercase it, and return it, just like that. Now we need to implement gift. So we could just return the dunder gift attribute, but that wouldn't work because if we were to ask for verse4.gift, we would get just the gift for that day. So instead, we need to construct a list, right? So if we were to do something like this would go through all of the enum members up to that day and put them into a list, and then we'd join them into a string. And that could work, sort of, because when we do that, it gives us a list, but it's in the wrong order, right? So I'm just going to change the variables in the range. So instead of starting from 1 and counting up to self.value, I'm going to start from self.value and work our way down by doing from self.value down to 0, taking a -1 step each way, if that makes sense. That gives us what we need: the 3 French hens, 2 turtle doves, partridge in the pear tree. But unfortunately, we're missing the and, right? So let's implement that part. So the thing I want to check for is if the list is more than one item, let's just add the string and to the last item. That's what this code does. And it looks like it's exactly what we want. So now that we have our enum, let's work it into our code. So back in our code, the question is, how can we kind of insert this in? And given that, I think the easiest way to insert this in is in the render verse function, because we have an integer passed in, and this is where it kind of works with the attributes, the nth and the gift, right? So we can just insert a line here where we just take that number, the integer that's a number, pass it into verse, and now we have this variable verse that is this verse object, right? So now we can replace each usage. First, let's replace nth, and then let's replace gifts, And now that we've done that, we don't need our nth function, so we can get rid of it. We also do need our gift function, so we can get rid of that too. And now that's our code. So the question is it clear now how to add this feature? And I think so, at least to me, right? Because what we can do now is we can take this code, which is just the gifts themselves, and make a subclass of the enum class. I'm going to call it traditional, because these are the traditional 12 gifts of Christmas, right? But we need to allow people to pass in verse information. So just because we have this, we essentially need to work this into our code. So I think we need to provide a parameter into our recite function. This will allow users to pass in verses. And I like having the type in here because it clearly explains you need to pass in something that's of type verse, which our traditional enum is because its subclass is verse. And so users of our code can do exactly the same thing. Unfortunately, we need to have a sane default, right? Because if we have any code that's calling our recite verse right now, it is expecting our traditional 12 days of Christmas. And so if we were to ship this code as it exists now, it would bomb out because Python would say you haven't provided a parameter for the recite function. So let's add our traditional class as a default parameter. And now we need to kind of work our way. Now that we've introduced the idea of a verse, we need to kind of put it into the rest of our code, kind of work our way through. So the first thing I'm going to do is work through the recite class. I'm going to, instead of generating a range of numbers and passing it into our render verse function, I'm going to take advantage of the fact that enums are actually iterable. And so now I'm just going to pass going to iterate through the enum and pass each member to our render verse function. So I think that's an elegant solution. So now we need to edit our render verse. Oh, first, right, we need to get rid of the line of code before that. And now we need to work on render verse and give it the verse. Give us the ability to pass in the verse. Well, now that we've done that, you look 2 lines below and we don't need that variable anymore. It's already a verse. So let's just get rid of that. And you know what? I just realized we've done a heck of a lot of work. It looks done. I'm going to run our test just to make sure that we're good. Okay, good. We're good. And you know what? Not only do we have passing tests, we've implemented our feature. Hooray! Now, people can make custom enums with the gifts that they care about, and they can create their own versions of the song, just like this. For people, I think this would be a great Christmas for me to get a first day of Christmas, get a subscription to PyCharm. The second day of Christmas to get 2 books in VS Code and a subscription to PyCharm. That sounds great to me. And that's about where we need to finish it. So I thank you for joining me here for the refactoring, to learn about refactoring. If you are interested in anything that I've said tonight, I want to let you know I'm available for team training, as well as I have a couple slots open for personal coaching. I really love Python. I think, I graduated college with an art degree. I taught myself programming and learned Python, and it has opened up so many doors for me. It's incredible. And I want to do the same for other people, So I've quit my job. I've started training. I want to be a coach. So if you think I can help you out, please DM me, let me know. I'd be happy to work with you. In addition, I have spent many months researching refactoring. And I mentioned before that refactoring, especially the code smells, and actually a lot of the material out there on refactoring is kind of specific to C and Java style languages. And so as a result, if you were, as a Python developer, if you were to grab a refactoring book or read a blog post on refactoring, chances are you're going to hear a lot of things that just don't make sense in Python. So I've spent a lot of time creating what I think is going to be a really valuable resource. And I'm calling it the Refactoring Toolkit. It's essentially if anybody has heard of is familiar with the program Obsidian, it's an Obsidian vault that is chock full of code smells of refactoring methods and other articles that I have used as my own personal kind of treasure chest toolkit of things to help me figure out refactoring and translate it from C and Java to Python. And man, I'm excited about this. I think it's going to be a great resource, and I think you should consider looking into it. It's at everydaysuperpowers.gumroad.com. And with that, I'm open to any questions. Thank you.